Okay, in this lecture we are going to continue with simple annuities. Just to remind you from the previous lecture, we derived the formula for the present value for an annuity. And that is the formula that you see on this slide. And we did some substitution to find the present value for our example. We can also do this on our calculator. So I encourage you to take out your financial calculator now. Okay, so to do the same example that we did by hand and by using the formula, we can do it on the calculator. So what are the steps that we follow? First of all, we clear any other information from previous calculations. So that's second function and CA. Okay, and then we enter the number of payments per year. So if you say second function, or if you press the second function button, so second function and then this button, payments per year. And then you type in a 12 because we are making monthly payments. So the number of payments per year will be 12. And we enter this. And then you go with the down arrow, you press the down arrow, and the compounding periods per year will be given as a 12. So you just leave it as it is. It is correct because we are working with a simple annuity. So the payment period or the number of payments per year is 12, and the compounding periods is also 12 because we are compounding on a monthly basis. Okay, and then you press the on-off button just to clear the screen. So that's the on or clear button. And then you continue as we did for previous compounding interest calculations. You put in your 18 and then your interest rate per year. So our interest rate per year is 18% per annum. Then you have 1,000, and now you press the payment button. We haven't done this before because we are now working with annuities. We have payments, regular payments of 1,000 rands each, and also the number of payments. So that is, for our example, we made 5 equal regular payments, and then you press your N button. And then you say compute present value. So it's compute and then your present value. And that will give you an answer of negative 4782.64. So again, similar to the previous calculations we did on the financial calculator, you must either have your payments as positive and your present value as negative, or if you entered your payments as negative, then your present value would be positive. So strictly speaking, the payments in this example must be negative, and therefore the present value or the original loan size, the original money you received will be a positive. But if you can do it whatever way you find easiest, just remember that if the payments are positive, the present value will be negative, and the other way around. Okay, so that was the using your financial calculator. Next, what we are going to do is we are going to find the future value of an annuity. Okay, so next we are going to find the future value of an annuity, and we're going to do that by looking at example 26. Determine the future value of a savings account when 5 monthly deposits of 1,000 rands each are made, when the interest rate is 18% per annum compounded monthly. So this example looks very similar to our previous example. In the previous example, we had a loan as our present value, and we made 5 payments to repay this loan. in this case, we have 5 deposits of 1,000 rands, and we would like to know the future value of this savings account. Okay, so let's do that again by hand. Okay, and we make our first payment, we make at time t1. And then we repeat that 5 times. And the last payment is at time t5. And we also want to find the future value at time t5. So to find the future value, we will move these payments forward. We will move them to time t5. So to move the first payment from t1 to t5, so I will call that future value 1. That will be my 1,000 rands, 1 plus my effective interest rate. I've moved it 4 time periods, 1, 2, 3, 4. So that is to the power 4. Then I move my second payment, I move it forward 3 time periods. My third payment, my fourth payment, I move it forward 1 time period. And then my last payment, I move it forward 0 time periods. So that will just be equal to 1,000 rands. So to find the future value of this annuity, I will add all these future values. And if you add them all, you get your future value, 5,152 rands. Okay, and again, this is a very tedious process, and we would like to find a formula for the future value of an annuity that will be a lot easier, where we can just substitute to get the future value of an annuity. Now, you will remember our geometric series, and again, you won't be examined on this, but I think it's very useful to understand where the formula for the future value of an annuity comes from. So remember that my geometric series is of the following form. And we say that the sum of the first n terms Okay, and now for our specific situation, if we go back to this slide here, our first term will be this one here. So my first term will just be the payment. If you go back there, the payment is just equal to 1,000 rands. And then to get to the second, the third, and so forth terms, I multiplied it. Each time I multiplied it with 1 plus the interest rate. So that will be my R, the factor that I multiply each term with. So my R, the constant factor, will be 1 plus IM. So now you can go and do your substitution into this formula. So you will substitute your A, you will substitute with payment, and your R, you will substitute with this factor. I'm not going to go through the whole process. You can go and do that in your own time. Okay, now you can do the substitution. If you take this A payment and R1 plus IM, and you substitute it into this formula, then you should get the formula for the future value of an annuity. So the future value of an annuity is given by the following. Okay, and this is then the formula that we're going to use to get to the future value of an annuity. It's a very important formula. You can add it to your list of formulas. So we have now added two new formulas. We have added the present value of an annuity, and we can now also add the formula for the future value of an annuity. I just see that that is a mistake. That should be 1. So there you have the formula, and we can redo our example. We can redo example 26 by just doing the substitution. So now we need not go through that tedious process. We can just substitute into this formula. So my payments, I made 5 payments of 1,000 rands each. My interest rate, 18% per annum compounded monthly, so that's 0.15 effective per month. My K is 5 because I made 5 payments. And then you can type this into your calculator and you should get the final answer. Okay, so that is a lot simpler than going through this whole process by just substituting into the formula. And then, of course, you can also do it on your calculator. Again, I'm not going to show you all the steps again. You can follow the steps in your notes. The only difference now is that you do it very similar to the present value for the simple annuity, but the only difference here is that we are not going to compute the present value, we are going to compute the future value. So try this on your calculator and see whether you can get to the same amount. So 3 different ways of getting to exactly the same answer: by doing it the long tedious way by hand, by substituting into the formula, and then also on your calculator.